Speak like a native. Live practical English conversation. Conversation between a neurobiologist and a student about memory.
Good afternoon, Jamie. I'm glad you're interested in learning about memory. It's a fascinating topic. Where would you like to start?
Good afternoon, Dr. Moreno. I guess the best place to start is the basics. What exactly is memory?
Memory is a process by which our brain encodes, stores, and retrieves information. It allows us to retain experiences and knowledge, giving us a sense of continuity in life. Without memory, we wouldn't be able to learn, communicate, or function effectively in the world.
How does the brain actually encode information?
That's a great question. Encoding is the first step in forming a memory. When you experience something, like reading a book or tasting your favorite food, your brain translates that experience into a neural code. This process often involves changes in the strength and efficiency of synaptic connections between neurons, a phenomenon known as synaptic plasticity. Have you heard of the term long-term potentiation, LP?
I think I've come across it in my readings, but I'm not entirely sure what it means.
LP is one of the mechanisms that underpins learning and memory. It refers to the long-lasting strengthening of synapses after repeated stimulation. When two neurons frequently fire together, the connection between them becomes more robust, making it easier for signals to pass. This wired together principle is a foundation for encoding memories.
Interesting. So once the information is encoded, how does the brain store it?
Storage involves the retention of encoded information over time. Different types of memories are stored in different regions of the brain. For example, the hippocampus plays a crucial role in forming declarative memories, like facts and events, while procedural memories, like riding a bike, are stored in the basal ganglia and cerebellum. The cortex is where long-term memories are often consolidated.
What about types of memories? Are there different categories?
Absolutely. We broadly categorize memories into short-term and long-term memory. Short-term memory, also known as working memory, holds information temporarily, usually for seconds to minutes. Think of it as a mental notepad. Long-term memory, on the other hand, can last for days, years, or even a lifetime and includes explicit declarative memory, conscious memories such as episodic memory, memories of specific events or experiences, like your last birthday, semantic memory, facts and general knowledge, like the capital of France, implicit non-declarative memory, unconscious memories such as procedural memory, skills and habits like typing or swimming, emotional memory, memories associated with emotions, often mediated by the amygdala.
What role do neurotransmitters play in all of this?
Neurotransmitters are crucial for memory formation and retrieval. For example, glutamate, the primary excitatory neurotransmitter involved in synaptic plasticity, and LP, acetylcholine, important for attention and learning, particularly in the hippocampus. Dopamine, involved in reward-based learning and motivation. Norepinephrine, helps modulate arousal and attention, which can enhance memory encoding. Deficiencies or imbalances in these neurotransmitters can impair memory processes.
What can destroy memory? Are there specific factors or conditions?
Unfortunately, many factors can harm memory, including neurodegenerative diseases. Conditions like Alzheimer's and Parkinson's damage neurons and disrupt memory-related brain regions. Trauma, physical injuries to the brain, particularly the hippocampus, can impair memory. Chronic stress, high levels of cortisol can shrink the hippocampus over time. Substance abuse, drugs like alcohol and benzodiazepines can interfere with memory consolidation. Nutritional deficiencies, lack of essential nutrients like vitamin B1 thiamine, can lead to conditions like Wernicke-Korsakoff syndrome. Sleep deprivation. Sleep is critical for memory consolidation, particularly REM sleep.
I've read that forgetting can sometimes be a good thing. Is that true?
It is. Forgetting isn't always a failure of memory. It's an essential function. The brain prioritizes relevant information while discarding the rest. This helps us avoid cognitive overload. There's also a phenomenon called synaptic pruning, where unused neural connections are eliminated, enhancing the efficiency of neural networks.
What about the role of technology? Does constant use of smartphones affect our memory?
Technology has a mixed impact. On one hand, it serves as an external memory aid, helping us store and retrieve information quickly. On the other hand, over-reliance on technology can reduce our need to remember things and may impact attention spans, which are crucial for encoding memories. Balance is key.
How do scientists study memory? Are there specific methods?
Yes, memory research combines various techniques, including brain imaging. fMRI and PET scans show activity in memory-related areas. Behavioral studies. Tests like recall tasks and recognition tests assess memory performance. Animal models. Rodents, for instance, are used to study LTP and the effects of drugs on memory. Electrophysiology measures neuronal activity in real time. These methods help us understand memory at both behavioral and cellular levels.
This has been incredibly insightful. Is there anything else you think I should know about memory?
One final point. Memory isn't just about the past. It shapes who we are and how we imagine the future. The same brain regions involved in recalling memories also help us simulate future scenarios, a process called mental time travel. Understanding memory is not just about understanding the brain, but also about understanding ourselves.
That's profound. Thank you so much, Dr. Moreno. I've learned so much today.
You're very welcome, Jamie. Keep exploring. The brain's mysteries are endless.